So welcome everybody. This is another one of our fellows visiting from the Institute for Cross-Disciplinary Engagement. And I'm very happy that Dan could make it, and not just could make it, but you actually stayed a while, which was great.
It's been great, yeah.
That's what we like. We like people that stay, and he's incredibly busy. He connected with a lot of different people, especially political sciences and philosophy, of course.
Yep.
Which is exactly what we want. And so Dan Singer comes from the philosophy department at the University of Pennsylvania, and he is a philosopher who seems to be almost doing like what scientists do, but with a mind of asking questions like a philosopher would, right? And the title of the talk is Rational Polarization and the Importance of Forgetting in Groups. Now, we live in very polarized times, right? Where we have a lot of discord and a lot of people that are from Holocaust deniers to, moonlander deniers to, I don't know if you're going to talk about any of this.
Not those particular examples.
That, people can forget certain things in groups. And if you're not going to talk about that, we should talk about it later. Because
great.
But the idea is that how you as an individual or as a person in a group change your mind or forget things or align your opinions depending on the dynamics of what's going on. And I think Dan not just has arguments about it, but he also runs computer simulations with epistemic agents to model these things, which will be very interesting to see. So Dan, thanks for coming. And
great. Thanks so much to you guys. Thanks Marcelo and Amy for making this happen. It's been really great to be in Hanover for the past few weeks. All right, so as Marcelo said, I'm going to be talking about polarization. You guys already know, anyone who's been alive for the past couple years or longer knows that we're very polarized. So here's some voting patterns from the Senate, getting more disconnected. Here's some data about the actual population, how people feel about whether or not the government should do more to help the needy, the role of racism in affecting various people, and whether or not the government should help with immigrants. It seems like we're getting more polarized about these questions. So a natural thing to ask is, where does polarization come from? What causes polarization? So here are some things you might think that cause polarization. So one thing you might think about what causes polarization is, look, we're just in different situations. So some of us live in the city, some of us live in the country. Those of us who live in the city might be focused on certain sorts of things like trash pickup. Those who live in the country have, I don't know, you guys probably know, have different needs. So we might just be polarized because we have different needs. We might also be polarized because we have different evidence about questions. So let's say we care a lot about tax policy. Well, maybe I know a lot about some area of tax policy and you know a lot about some other area of tax policy. And because we have different evidence about the tax policy situation, we might disagree about what the most effective tax policy is. A last option you might think is we might just disagree. So we might have all the same information about tax policy. We might know all the facts about fetuses and what's going on in their cells. And we might just disagree about whether or not abortion is permissible or whether or not this is the most effective tax policy, even if we have the same evidence. OK, so the standard view among social psychologists who look at this sort of thing is that kind of belief polarization. The last kind is irrational. So what do they mean by that? So belief polarization, the way that social psychologists talk about it, is increased disagreement after seeing the same evidence. So if you have two people and they see the same thing and then their beliefs get further apart, that's belief polarization. So why is that supposedly irrational? Well, a really natural thing to think is this: uniqueness. So philosophers have talked a lot about this thesis, uniqueness. Uniqueness says, given some set of evidence, there's only one right thing to believe in light of that evidence. So it doesn't necessarily have to be a belief. Sometimes evidence, you should just suspend belief about the question given some evidence. But it can't be the case that it's rational to believe that grass is green in light of the evidence, but also rational to believe that grass is purple in light of the evidence. That's not OK. So if you buy that, then that belief polarization is irrational should seem right to you. If we share our evidence, then we should be getting closer together in what we believe. So if we're doing this irrational thing, what causes it? Well, social psychologists have had a lot to say about this. So there's a bunch of different views in the literature. Probably the most well-known one is this view from Lord et al. So Lord et al. Think that there's two bad things going on. There's biased evaluation and biased assimilation of evidence. So what I take the evidence to be supporting, I evaluate the evidence based on what I already believe. So I take it to be more likely to support my view, whatever that is. And then whether or not I take on board that evidence, actually let it affect my belief, is also a function of what I believe. So Lord et al. Actually think that biased evaluation is fine, and they give a defense of that, and they think that biased assimilation is bad. But either way, they think there's something irrational there. There's lots of other theories of what could create belief polarization. So maybe it's motivated reasoning. I just really want to be someone who's pro-choice. Or maybe it's I want to identify with a social group. I really like Democrats. They have the best beer. Or maybe it's just that I don't want to not be sure about something. So these are all views that are argued for in the social psychology literature. A common theme here, as I said, though, is that they all treat belief polarization as irrational. So Ross and Anderson sum this up very clearly. They say belief polarization is in contrast to any normative strategy imaginable for incorporating new evidence. So if belief polarization is irrational, that would be, in a sense, good for society, right? Because then we could try to correct that irrationality and get rid of the polarization that we see in politics. I guess what I'm going to argue for here is some bad news. So belief polarization is not necessarily irrational, is what I'm going to try to convince you of. I made this myself. OK, so here's the plan. So I'm going to give you a methodology. Marcelo basically summed up the methodology already. It's do science, but I'll say a little bit more. Then I'm going to do the science. So I'm going to give you a way of thinking about group deliberation or society deliberation about questions. Then I'm going to tell you about a model. And then I'm going to give you some results from running the model. It's a simulation. And then I'm going to argue what's going on in the models, that it's agents acting rationally. So just seeing the model is not going to entail that what they're doing is rational. So I'm going to have to make that argument separately. And then at the end, I'm going to draw out some more implications of this, of the model I mentioned. Before I go on, I want to mention that the work I'm discussing here is done on the model of science, which philosophers, with the exception of at least one philosopher in the room, actually, but most philosophers don't do philosophy on the model of science. But these folks and I are in a lab group together, and we do this together. So here it goes. All right, so if we're doing science, we want to understand complex phenomena. What do we do? Most of you are scientists, so I take it that this will come naturally to you. So we have the San Francisco Bay, and we're trying to decide whether or not the plan to dam the bay is going to be a good plan or not. So something we could do is we build the San Francisco Bay model, and we run some tests. We use other kinds of models. We teach undergraduates predator-prey models, Volterra equations. One kind of model that is common to see is agent-based models. So what's going on with agent-based models? So agent-based models have these features. Some things that are going on in agent-based models, there's usually simple agents, so really simple objects. And those simple objects interact in simple ways. And then what comes from that is supposed to be complex emergent phenomena. So these models are useful for trying to understand complex phenomena, trying to understand how simple mechanisms could give rise to patterns that look complex. Agent-based models often involve an element of simulation, usually over time. And they also often involve some kind of stochastic process, random decisions, things like that. So when we look at agent-based models, there's two different kinds of agent-based models. So I made up these terms, but you'll get the idea. So there's thin agent-based models. So thin agent-based models are incredibly idealized. The goal of thin agent-based models is to help us understand what's going on. So they often provide how possibly explanations. Like Conway's game of life is like this. How can we possibly have a system that operates under these simple rules that keeps creating something new? Oh, here's a way to do it. We have this simple model. So that's a thin model. On the other hand, there's thick models. So thick models are realistic. They include lots of moving parts. They try to get all the different mechanisms that might be real in there. And they're usually used for prediction. So if you want to know where the hurricane's going to go, you don't just want your simple model of a hurricane where you have perfect swirling. That's not going to tell you whether or not this area is going to be flooded or that one. Instead, you want a really realistic model. OK. So here I'm going to be giving you a thin model of group deliberation. In the discussion about models of group deliberation, there's a lot of thin models. Most of them, though, are of this structure. They're models that have been discussed by a bunch of people. So depending on what field you're in, you may identify with one of these names. But French, Haré, de Groot, Lehrer, and Wagner are all folks who use these kinds of models. So what's going on in these models is this. We start out with a bunch of agents. In the simpler models, it's just a bunch of agents who are all talking to each other and everybody can hear everybody. In the more complex models, maybe they're on networks, so they're social networks. We start out with a bunch of agents, and they all have some belief. And we'll model their belief as just a number between 0 and 1. So you could think of this as maybe their belief about how effective some particular medicine is or something like that. And then the agents all have neighbors that they talk to. It might be everybody if you've got a really simple model, or it might be just their neighbors on the social network. And then on each round of the model, they do something like averaging to update. So they talk to all their neighbors. They say, oh, I'm a 0.5 person, and Marcelo is a 0.9 person. So next I'm going to go to the average of 0.5 and 0.9. And so there's lots of extensions of these sorts of models, but there's a lot of discussion of models in the belief dynamics literature that work something like this. So it's been known for a long time, and if you try to program this, if we have undergraduates do this at Penn, but if you try to do this, you'll probably get a model that converges. So Abelson puts it this way: ultimate agreement is a ubiquitous outcome of a very broad class of mathematical models. And later on he says, what on earth must one assume in order to generate a bimodal outcome? Any kind of model like this, you can see everyone's going to collapse, because if you're doing something like averaging, everybody's just going to get closer together in what they believe.
Does it matter how many neighbors you can talk to?
There are ways of doing thin agent-based models with averaging like this where you can get polarization. So Abelson was actually wrong. Hegelsman and Krauss have a model like this from 2002 and a better version in 2004 where they do this sort of averaging and get polarized societies. And the way they do it is, if you only talk to people with beliefs near yours, then you could get groups that form. I'm happy to talk more about that later. It is possible, but I'm going to give up on the averaging models altogether. So, all right. So here's a new model of group deliberation that doesn't involve any kind of averaging. OK, so here's going to be the starting part. To model group deliberation, we're going to start with this idea that rational belief, what a group should believe, what a person should believe, is what's supported by their evidence or what's supported by their reasons. So an agent's going to have a bunch of reasons, and what they should believe is what's supported by their reasons. And then deliberation in this model is going to be the exchanging of reasons. So I believe that abortion should be permissible. Why do I think that? Well, here's my reason. OK, now we're discussing. In these particular models, we're going to assume that everyone hears everyone. And there's not going to be any analog of like shouting or threats or anything like that. One more thing about the model. The last thing is that in this model, sometimes agents are going to be able to get reasons from the world. Because we don't always figure out what we believe from each other, right? We learn a lot from each other. But sometimes you go out in the world, you do an experiment, and you figure out something somebody didn't tell you. OK, so you can also get reasons from the world. So 12 Angry Men, the juror goes to is it juror 8, goes to the pawn shop, finds the knife that's supposedly rare. OK, that's a reason to think that the knife wasn't as rare as we previously thought. That's a reason from the world. All right, how are we going to model reasons? A reason on this model is going to be a very simple thing. It's just going to be a thing that it supports, thinking that the 18-year-old is guilty of murdering his father, or not. And then it's going to be a strength at which it supports that content. So a reason is just that. There's nothing else to a reason in this model. It's just guilty or not guilty, and then a strength, so maybe 3. So here's a little picture. So reason A is just a supporting of guilty with strength 3.2. And for the models I'm going to show you, we're going to make some simplifying assumptions. So we're going to assume there's just 2 contents we're discussing, guilty, not guilty. We're going to assume there's lots of reasons. So here you can think jury trial again. So there's lots of things that might bear on whether or not this 18-year-old actually did kill his father. But few of them are very strong reasons. It's quite rare to have an eyewitness who says, look, I saw this guy do that at that time. Right, okay. So then if we were to plot out the reasons, they might look something like this. So we'll give the reasons a positive strength if they support guilty, a negative strength if they support not guilty. Then there's going to be lots of reasons of strength 0 or near 0. They don't tell you much about guilty or not guilty. There's going to be very few reasons that tell you one way or the other. And then what we're going to say is that a person's belief is just the weighted sum of whatever reasons they have. OK, so that's going to be the model of reasons. Obviously, this is incredibly simple, and you might think there's a worry here. So one worry is that that stems from this idea that the reasons just have basically no structure. They just support some content with strength. The worry is that we can't even do simple interactive things with groups. So oftentimes what happens when you have a group discussing is that you could have 2 people say different things, and those things come together to support something that neither individual part did. So maybe I know P, and Marcelo knows if P, then Q. Well, then if I say P, and Marcelo says if P, then Q, then we can collectively conclude Q. right? But neither P nor if P then Q by themselves supports Q, right? So you might think our model of reasons is just too simplistic, right? It can't capture group deliberation. And the response to that is going to be a few things. So one, we're trying to give a really simple model. It's supposed to be a thin agent-based model. Here's another move if you don't like that. You could think of the reasons as lines of argument. That doesn't really get around the objection, right? But okay, then in our model, people can only exchange lines of argument for conclusions. They can't actually have this back and forth thing. But the last response is I'm going to come back to this, so we have a better response. But for now, just go with it. All right, the last element of the model is going to be memory. So some agents, according to epistemologists, but not according to anybody else, have perfect memory and never forget anything. But real agents are never like that, right? We all forget things. We have limits to how much we can remember. So if we're going to model this, we need to have ways that agents forget. So how are agents going to forget things? So one way they could forget things is when their memory gets full, they could just drop something at random. So that's really bad computer design, but you could do it that way. Another thing you could do that's plausibly more rational is you could forget the weakest reasons, the reasons that have the lowest strength. Forget those first because they don't bear as much on the conclusion. Here's another thing you could do. You could forget reasons that go against what you believe. So at any moment in time, you're going to have a collection of reasons. They'll collectively support something, guilty or not guilty. And you could look at your collection of reasons and go, OK, they collectively support guilty. So if I have to forget something, I'm going to forget something that supports not guilty, because that's a misleading reason. OK, so those are three ways that agents could forget. So we're going to simulate this, and I'm going to show you some results from simulations. I'm going to show you two different kinds of runs. So in the first kinds of runs are going to go like this. So there's going to be 50 agents, and at the beginning they're all going to get 7 reasons, just each agent will get 7 random reasons from the world, possibly different ones. These numbers don't actually matter at all. We've done tons of robustness testing, and for all interesting numbers, these results work. But I'm going to show you numbers for these. OK, so 50 agents, they all get 7 reasons. And then a random person just says a random one of their reasons. Everyone's going to hear that reason, take it on board, adjust their belief. And then if the agents are limited, then everyone who has more than 7 reasons is going to forget one. So if everyone starts out with 7 and then a random person says a random one, well, not everybody's going to have more than 7 now, because the person who's speaking is not going to have more than 7. And if people already had that reason, they're not going to have more than 7. But if somebody now has 8, they're going to forget the reason using whatever forgetting rule we're simulating there. OK, so that's pure deliberation. It's really simple. All that happens is we have this setup. You get your reasons, and then we do this repeating thing where a random person says a random reason, everybody adjusts their belief, and then everybody forgets if they need to. And then repeat. A random person says a random reason, everybody adjusts their beliefs, everybody forgets if they need to. The other kind of run is going to be deliberation with outside input. Deliberation with outside input is very much like deliberation, the pure deliberation cases, except that before anybody says a random thing, everybody's going to get a reason from the outside world, just some random new reason. And that's going to repeat. So what's going to happen here is everybody's going to get a new reason from the outside world. One random person is going to say one random thing. Everybody's going to hear the reason that they said and adjust their belief. Then they're going to forget if necessary, and then repeat. Everybody gets a new reason from the outside world. Someone says a random thing, yada, yada. All right. So that's how we're going to do these simulations. If we're going to do these simulations, we need some ways of measuring the output. It turns out to be very difficult to specify formal measures of polarization. So sociologists have thought about this a lot. And if you look at actual sociological work, there's lots of folks aren't very clear about exactly what the right measures of polarization are. My lab group and I have published a couple papers trying to clarify different ways you could measure polarization. So we have a paper in the Journal of Mathematical Sociology where we lay out 9 different measures of polarization. Here I'm going to give you 3 of the measures. The first one's not one of them. But I'm going to give you 3 of them for the sake of demonstrating the point. So if we're going to measure a group, so say we have a belief histogram. Here's all the people. Their beliefs are jumping around. One thing we might measure about this is how quickly they converge. So if the group converges, how quickly does it take them to converge? And there's 2 different kinds of convergence that we could get. So one, we could get how quickly does it take them to converge on a view? How quickly does it take for everyone to be a believer in guilty or a believer in not guilty? Another question we could ask is how long does it take for them to converge on a set of reasons? So not just everybody believes they're guilty, but everybody believes the person's guilty for the same reasons. Why are we measuring convergence? Well, because if a group converges, there's no polarization, right? Converged groups aren't polarized. Here's some better measures of polarization. So another measure of polarization that we could use is group divergence. So group divergence measures the means of the groups. So group B here is more polarized than society A. So in A, the means are this far apart, and B, they're this far apart, so they're more polarized. Right? That's a natural sense of polarization. Here's another sense of polarization: how much consensus there is within the subgroups. So society A is less polarized than society B, because in society A, there's more variation in what it takes to be a red person versus, and more variation in what it takes to be a blue person. In society B, the red people and the blue people are much more in agreement. So that's more polarized. Something to notice here is that the means need not be different among these groups. So the first measure doesn't capture that. A last measure that we'll use is size disparity. So here, society A is more polarized than society B, because the groups are approximately the same size in society A, whereas in society B, the minority group is just a small part of the society. All right, if you're doing an agent-based model, you have to have a movie. So here's the movie of the model running. It's got a fun GUI. So up there, we see there's our 50 people, and they're all talking, and whether or not they're on one side or the other is symbolized by their color, red or blue. Here's the belief histogram, giving away that there's a way that this could polarize. There's the reasons, and we've got lots of measures of polarization. OK, so here's some results. So if we look at pure deliberation, what do we get? Well, we get lots of groups that converge, just like you'd expect. So if we have unlimited agents, they converge. Why do they converge? Well, everybody ends up saying all the reasons they have at some point, because everybody's just saying random things. So then everybody hears all the random things, and then eventually everybody's got all the reasons that can be had. So they converge, but it takes a really long time, and they just kind of squeeze together. Simple-minded agents, those are the people who forget at random, they also converge. Why do they converge? Well, stuff gets thrown out at random, both in the sharing way, but also in the forgotten way. So eventually, there's just a small set of reasons that haven't been randomly forgotten. Weight-minded agents, those are the ones who care about the weight of the reasons and only forget the weakest reasons. They converge, and they converge even faster, which makes sense, right? Because they're all going to forget weak reasons. So if a weak reason gets thrown out, that's going to be a prime candidate for being forgotten at the next round, right? So they have a systematic way of forgetting things, so they converge a lot more quickly. The surprise result, which is not a surprise at all, given how I've set up this talk, is that coherence-minded agents don't converge. Well, they can converge, but it's very rare that they converge. So it's only about 4% of the time that coherence-minded agents will converge with the particular parameters that I've given you. We can also see that coherence-minded agents are highly polarized when we look at the group divergence, so how far away the means of the two groups are. So if we look at unlimited agents or the random agents or the weight-minded agents, the means of their groups always come together. But with coherence-minded agents, as a general rule, the means of their groups get separated. What you're looking at here is each one of the small red lines is one run, and then the thick red line is the average of 100 runs. So a very small number of coherence-minded groups do converge, but otherwise the means of the group separate. If we look at group consensus, how tight-knit the groups are inside, we also see that with coherence-minded agents, that goes up over time. So the groups, their means go further apart, and they get more tight-knit. And we get really even splits with coherence-minded agents. So more than 70% of the time, at least 20% of the group is in the minority group. Roughly 30% of the time, the minority group is at least 40% of the population. So that's pretty close to a 50-50 split. And it's incredibly rare that there's only one or two agents in the minority group in these simulations. So we get lots of polarization with coherence-minded agents. What about in deliberation with outside input? What should you think intuitively? Well, with outside input, what's going on is that every agent is getting a reason from the world before a small amount of sharing. Only one agent says some random thing. So you should think we're going to get a lot more consensus, right? Because we're getting a lot of reasons from the outside world, so we're gaining a lot of information really quickly. And that's basically what we see for most of the agents. So for unlimited agents, they converge a lot faster this time, on average in about 400 steps compared to 60,000 before. Weight-minded agents also converge faster. The random agents, they also converge. Sorry, they actually don't converge, but they meander. Why do they do that? Well, because they're forgetting things at random, and then they're getting new random stuff. So they're just kind of going all over the place. So they do something like this. They start out kind of spread, but then they become a blob, and the blob just kind of moves back and forth for a while, and it never converges. What about coherence-minded agents? Well, they converge almost never with outside input. So convergence happens less than 1% of the time, down from about 4% of the time before. When convergence does happen, if you look at the actual run, something weird is going on in those runs, because it almost always happens within 8 steps. So those might be runs where basically everybody was on the same side to begin with, just due to the stochastic setup of the process. So something weird is going on in those runs where there is convergence. And we get an increase in the group disparity. Sorry, a decrease in the disparity, an increase in the parity. So here, over 92% of the runs have at least 20% of the group in the minority. So you get, pretty big groups almost all the time. We also get higher consensus in the subgroup with outside input. So the axes are not the same here. Same with group divergence. Subgroup divergence, how tight-knit the groups are. The groups are more tight-knit with outside input than when they are with pure deliberation. Here's a summary table, which I expect no one to read, but the upshot is this. The upshot is that you only get polarization with coherence-minded agents in this model. And when you have something that, for other groups, makes them less polarized, namely the outside input, it makes coherence-minded agents more polarized. So it seems like coherence-minded itself is what's causing the polarization. OK, so what's going on so far? So I've given you a model. In the model, we've got these coherence-minded agents. I've argued that the coherence-minded agents, in fact, will polarize, given some parameters that I haven't told you enough about, which you should feel free to ask about in the questions if you'd like. It happens. It's quite robust, though. The result happens in lots of situations. But I haven't argued anything about the rationality yet. So what I need to convince you is that coherence-mindedness is rational. It's a rational thing for agents to do. Because if it's not rational, then I haven't yet shown you that we can rationally get polarization. So that's what I'm going to try to do. I'm going to try to convince you that coherence-mindedness is a rational way to manage your memory. Before I do that, it's worth highlighting exactly what's going on here. So in discussions of rationality among economists, among philosophers, usually what you're talking about is what it's rational to believe. So given you have such and such evidence, what's rational to believe? So like Bayesianism is a theory of what's rational to believe. Right? What we're talking about here, though, is not about what's rational to believe. It's about what's rational to forget, which is a quite odd thing to talk about. Right? That's not something, I've never seen a theory of what's rational or not to forget before. But OK, so one way to put it is that we're thinking about rationalities, the rationality of forgets rather than the rationality of beliefs. That obviously comes very unnaturally. So maybe we could talk about it in terms of the rationality of certain techniques for managing your memory. You could put the question that way, but it's worth noting that that makes it disanalogous to the rationality of beliefs. Because we could ask, if we were economists or philosophers or cognitive science, we could ask, what's a rational way to manage our belief formation? And we could ask, what's the rational belief? And those seem like two different questions. So equally here, you could ask, what's the rational thing to forget? Or what's the rational management strategy to have for your forgetting? And those might be two separate questions as well. Here, I'm going to be a little ambiguous. All right, so I'm going to try to convince you that coherence-mindedness is a rational forgetting strategy, or yeah. The natural thing to think here is that I'm obviously wrong, because the natural thing to think is that weight-mindedness is obviously the rational strategy. Why is that the intuition? Well, weight-mindedness says that you should maximize the informational import of your reasons. Right? Remember, the weak reasons are the reasons that don't tell you very much about what's going on. The strong reasons, those are the reasons that give you a lot of information. So if you want to be rational and you know that you've got these limitations, it seems like the right thing to do is maximize the amount of informativeness you can get. And that's what weight-mindedness tells you to do. There's a problem with weight-mindedness, though, that I think makes it irrational. So weight-mindedness requires you to do a very odd thing. It requires you, in some circumstances, to knowingly let your future self have a belief that you know is not the best belief that that future self could have. So let me give you an example. I call this the forced ignoramus problem. You force yourself to be stupider than you could be. So let's say you start out and you've got a memory limit of 4, and you start out with these 4 reasons: a positive 6, a positive 7, a negative 6, and a negative 8. I made those the numbers so it's easy to do the math in your head, negative 1. And then you get a new incoming reason of 5. So what's going on here? Well, maybe you're you're trying to decide, did I leave my keys in my office or did I leave my keys at home? And you go, well, I usually leave them on the side table by home, and I think I remember doing that. But today I went into my office, and I often leave my keys at my office. Okay. And so I get this additional reason 5. My partner told me they saw the keys at my house, and that convinces me overall that I left the keys at the house. So your total evidence supports P, or positive, with 4 strength before you forget. So you have to forget something here because you only have a memory limit of 4. Well, what should you forget? Well, if you're a weight-minded person, you're going to forget this 5, the last thing that came in. Why? Well, not because it's the last thing that came in, but because that's the weakest reason you have. But if you forget the 5, you'll end up thinking the keys are in your office. And that doesn't seem like the rational thing to do, right? If you know that your future self is going to have a belief on strictly less evidence than your current self has, then you shouldn't let your future self have the wrong belief, right? That's actually kind of weird. So philosophers think about cases like this, or cases that are sort of like this, where your future self has more evidence than your current self. What should you think about that person? This is the opposite of that. This is a case where you know that your future self is going to be stupider than you currently are, and you have to help them. So if you're going to help your future self, what should you do? Well, you shouldn't let your future self have the wrong belief if you can prevent it. And of course, you can prevent it. Coherence-mindedness, along with lots of other strategies, never allows you to change your mind. You would never change your mind if you're a coherence-minded person. Okay, so that's a problem with weight-mindedness. I haven't given you any argument for coherence-mindedness yet. I've just pointed out that coherence-mindedness doesn't face this problem. You might have a worry about coherence-mindedness. A natural thing to think about coherence-mindedness is that coherence-minded agents are biased. I started out the talk by saying one of the going views about belief polarization in social psychology is that it comes out of this bias collection of things that we do, biased evaluation and biased assimilation. And the view there was that that's a bad thing to do. We shouldn't treat our evidence in this biased way. And you might think that coherence-minded agents are equally biased. But they're not. Coherence-minded agents don't do either one of these things. So what do coherence-minded agents do? Well, they first take on board whatever reasons they got. So you're in this deliberation. You're a coherence-minded agent. You take on board the new reason you got. You don't ask yourself, should I take it on board based on what I believe? Nope, you take any new reason on board. And then in light of all the reasons that you have that go over, including this one that goes over your memory limit, you decide what to believe. And then you forget a reason. Right? So you're never treating incoming evidence in any kind of biased way. It doesn't seem like you're treating any of your evidence in a biased way. I'm happy to try to argue. OK, so this is not an objection to coherence-mindedness, I don't think. So what are some arguments for coherence-mindedness? One way to argue for coherence-mindedness is just to say, look, having a coherent belief state, that seems like a good thing. And if you buy that, then the argument to coherence-mindedness isn't very hard, because coherence-mindedness gets you to have a coherent belief state. If you really like that line of argument, you'll probably notice this problem. That line of argument should point you towards forgetting the strongest reason that goes against you, not the weakest reason that goes against you. And that strikes me as overly biased. My thought, what I actually believe, is that coherence-mindedness is a rational strategy. But there's lots of rational constraints, so you're required to respect your evidence too. So those two things together require you to forget the weakest thing on the other side. If you don't buy that and you really love coherence and you really want to go, no, it's all about coherence, well then, fine. Have a view called super coherence-mindedness, where you forget the strongest thing on your opponent's side. Then you're going to get more polarization. That's pretty easy to prove. So the argument will go through too if you like that view. Here's another argument for coherence-mindedness. Here's a view. I call this view rational dogmatism. If you rationally believe P, so if you believe that you left your keys at home for good reason, and you get some new evidence that not P, your son says, oh, I saw your keys in your office. Why are we in my office? Doesn't matter. OK. I saw your keys in your office. So if you get some new evidence that not P, then you have to do one of the two following things. You either have to think that that new evidence is misleading, or you have to give up your original belief. You can do both, but you have to do one or the other. So you either have to think, nope, my son is lying to me, or whatever, or he was confused. Those weren't my keys. Those were my colleague's keys. Or you have to stop believing that your keys are at home. Yeah, OK. So from that, we can get coherence-mindedness. How does that go? The argument goes like this. Rationality requires us to view opposing evidence as misleading. So opposing evidence meaning evidence that goes against what you believe. So if you haven't given up to the belief, it's opposing evidence, so it's misleading. Misleading evidence is bad evidence. You shouldn't base your belief on bad evidence. So you shouldn't hold on to bad evidence over good evidence when you're forced to make a choice. So if we have to forget something, we should forget opposing evidence. Again, like on the last slide, you might think that this says, well, look, then we should forget the strongest reason on the opposite side. And again, yeah, you'll get polarization if you do that too. I'm inclined to think that's not right because I think there's many constraints of rationality, but the argument will work if you think that. OK, so those are two arguments to think that coherence-mindedness is a rational way to manage your memory. Here's some objections that need to be dealt with. So one is the objection I brought up earlier, that this model is just way too simple. So the model structure is like this. Agents have reasons. Reasons are just pro-cons for guilty, not guilty, right? They're a supported strength. They're guilty, not guilty. And then supported content, and then a strength. And then discussion is just exchanging of these reasons. And the problem, recall, is that real group deliberation, real group discussions allow us to do these additive things where I can say something and you can say something, and those can collectively be worth more than either one, than just the addition of the two, right? P by itself doesn't support Q. If P then Q doesn't support Q, but the two together support Q. So then the response, so I gave you some responses to that earlier. Better response is, here's a new model. So in the new model, agents have propositions. They remember propositions. And some sets of propositions are arguments. And arguments are going to have a conclusion and a strength. So the argument is going to have some conclusion, guilty or not guilty. And then it's going to have a strength at which that conclusion is supported. And then discussion in this new model is going to occur by exchanging propositions, not by exchanging arguments. So here was the old model. It was just A, and it supported guilty with some strength. In the new model, it's not much of a variation. We have some collection of propositions, and those collectively support some content. So here's what is added. In this new model, different agents can contribute different parts of the discussion. So I can say B, and Adina can say C, and Marcelo could say F, and then we can collectively conclude guilty with strength 3.2. Another virtue that this model has is that we can have the same premises occurring in different arguments. So if you and I disagree over whether or not F, well, if we have B and C and we disagree about whether or not F, then I might conclude guilty from F, whereas you might conclude not guilty because you have B, C, and D, where B, C, and D is some other argument for not guilty. And so what that shows more generally is that this model is logic insensitive. So you can plug in any logic you want. Well, not any, but most things that people treat as a logic, you can model with this model. All right, so we've got this whole new model. It's slightly more complicated than the old model. The important thing, though, is that it gets around the objection that we were considering, but you get the same qualitative results. You get polarization if you implement the forgetting strategies in the same way, and so, OK. Another objection then. So another objection is that the model lacks social networks, and real discussion doesn't occur, with everybody, all 306 million of us standing in a room, and I go, here's why abortion is permissible, and everybody hears me. That's not how it works, unfortunately. So this is a feature of the argument, not a bug. So why is that? Well, because if you have social networks, it should be easier to get polarization, right? If only some people can hear the arguments, the pro-choice arguments, and only other people can hear the, let's say, anti-choice arguments, then you should expect polarization to be easier in that situation. So the model where everyone can hear everyone makes it more plausible that this is rational polarization that's occurring. Another objection along the same vein, you might think that the evidence distribution that I chose that looked like this, where we've got most of the reasons don't support much at all, and there's a very small number of reasons. You might say, look, very small number of strong reasons that support one thing or the other. You might say, look, that doesn't mirror our real discussions at all. In our real discussion at all, there's really good reasons to be a pro-choice person. There's really good reasons to be an anti-choice person. So maybe the So maybe the distribution looks like that, not like that. But again, this is a feature, not a bug. If the distribution of reasons look like this, then we should expect it to be easier to get polarization, because you'll have the people who have these reasons and people who have these reasons. So this is going to be the distribution of reasons where it should be hardest to get polarization. So the fact that we do get polarization there makes it a better argument. I mean, if you run this, you also do get polarization. We checked that just to make sure there wasn't something weird going on, but yeah. OK, so mini recap. So I gave you a new model of group deliberation. I showed that in this model, some of the agents, the coherence-minded agents, polarize. I tried to convince you that coherence-mindedness is a rational strategy for managing your memory. So then I can conclude that polarization can occur from rational updating on shared evidence, which was the goal. All right, so a couple more minutes before I wrap up, and we can have some questions. So recall the new model. So in the new model, agents remember propositions, not reasons anymore, and then some collections of propositions or arguments, and those arguments support some content with some strength. And then discussion occurs by exchanging propositions. So again, the idea is something like this. Something that becomes much more natural to ask when you're looking at this model is, how should agents decide which reasons to share? So we tell people how to share information all the time. If you see an abandoned briefcase on the subway, you're supposed to say something, right? You're not supposed to just speak at random. OK, so in the old model, the agents just, we had a random agent, and they just said something at random. But we might model where that doesn't happen. If we look at social psychology, there's lots of research on how people decide what to share. So the hidden profile paradigm is a large research area where the main kind of thread is that people in group discussions tend to not bring out the information they have that hasn't been shared already. People tend to focus on information that's already out there, which seems like a really bad thing. And then if you look at popular literature and some academic literature, you'll see lots and lots of advice about how to run better group discussions. So here's a fairly recent book by Cass Sunstein and Reed Hasty about how to run better group discussions. And there's lots of advice in here about, like, oh, should you have a devil's advocate, or should you have a red team, things like that. So what are some ways that we might have agents share? So thinking just really simply, so we could have agents share at random. We already had that in the first model. Another thing that agents could do is they could share influentially. What that would mean is they look at everything that's been said already in the discussion, and they say, what piece of information do I have that would most influence this discussion? That would just add the most information. That would allow us to conclude more, whatever that means in terms of what we conclude. Another way they could do it is they could share biasly. So they could say, I'm not going to contribute the thing that helps, gives us the most amount of information. I'm going to contribute the thing that helps pull the group discussion in my direction, whatever my direction happens to be. Influential and biased are both ways of implementing this idea that if you have something to share, you should share it. Right? One way is a kind of adversarial way, and the other way is a kind of just if you have something, anything at all, even if you don't think it's right, you should add it. So how much do these matter? Well, we modeled these, and we have some results. So if you model these, they make a difference. So the top row there is people who share at random. The middle row is people sharing influentially, and the bottom row is people sharing biasly. What are we measuring here? What we're measuring is the percentage of agents who have the true belief. What do I mean by true belief here? I just mean the belief that's supported by all the reasons. I actually mean argument, but since the argument model is a strict extension of the reasons model, I'll just talk in terms of reasons. So truth will just be what's supported by all the reasons. If you don't like that, that's fine. I think that because I think of reasons as facts, and what's supported by all the facts is what's true. But again, if you don't like that, that's totally fine. You could just hear the percent of agents who have the true belief as the percent of agents who have the belief that's the belief they would have if they had all the reasons that are havable. OK, so if we look at the percent of agents who have all the reasons, who have the belief that they would have if they had all, right, OK. If we look at that, what we see is that influential agents do a much better job of getting everyone on board with the truth than either random agents or biased agents. Perhaps the surprising result here is that biased agents actually do worse than random. So that seems bad. So what does this do? Well, this vindicates this idea that it's worthwhile discussing how we should share things. So the Sunstein, Hasty book, maybe that's a good thing we should be doing. We should be looking at these different ways of sharing information. But how much does sharing information matter? Well, that was for unlimited agents. What if we look at agents who have random memory? Well, if we look at agents who have random memory, how much difference the different sharing methods makes is a lot smaller. Not only is it a lot smaller, but here, bias sharing actually does better than either of the other two sharing methods. What about agents who are weight-minded. Well, again, here, how much difference this is made by the sharing methods is much smaller than it was for unlimited agents. And same pattern applies for coherence-minded agents. The amount of difference made by sharing methods is not that much compared to unlimited agents. So if you look, so we have 384,000 samples of this, and if you look at all the data across all the parameters, you see that in general there is a consistent pattern here. With p-values like this, with the data size we have, I don't actually consider this significant, but whatever. Okay, so there's a difference between these different sharing methods. In general, bias sharing actually does better than influential sharing, which does better than random sharing, which is not the pattern that you get with the unlimited agents. Again, these p-values are, in my mind, questionable. What about the forgetting methods? Well, it turns out the forgetting methods actually make a much bigger difference to the percent of agents who have the true belief than do the sharing methods. So here the p-values are significant in what I think of as an intuitive sense. So here, weight-minded agents do significantly better than either one of the other methods. And in average, that's by about 3%. 3 percentage points. 3% of the groups, 3% of the group is on the truth. 3% more is on the truth. And then both of those methods do better than random. Coherence-minded does about 7.5% better, and then weight-minded does about 10.6% better. All right, so it seems like forgetting matters a lot. So maybe we should be thinking about forgetting. Well, another way to look at this is to see how much of the variance is explained by forgetting rather than the sharing methods. So if we do that and we look at just the number of agents with true beliefs after we've run a bunch of steps of the model, we see that forgetting explains 86 times the variance that's explained by the sharing methods. So it seems like forgetting is a much, much better predictor of how the group's going to do than the sharing. If we look at the number of agents who have the true belief after just 10 steps, that's not what we get. Sharing actually explains 3 times more of the variance at that stage than forgetting does. But that's going to be the exception on this pretty long list. So if we ask maybe, does the group belief stop evolving before 1,000 steps? Does that ever happen? In answering that question, forgetting explains roughly 82%, 82 times the variance explained by sharing methods. If we ask how quickly it stopped evolving, given that it stops, again, forgetting explains a lot more of the variance. If we ask, does the group converge before 1,000 steps, so not just stop, but everybody agree on something, forgetting explains 50% more of the variance. If we ask how quickly the group converged, given that it converged, forgetting explains about just as much of the variance as the sharing. And if we ask the question whether or not it converged on the truth, given that the group converged, forgetting explains 2.4 times the variance than does sharing. So why does this all matter? Well, or why does forgetting matter? Well, here's a kind of cartoon picture of group deliberation that you could have in your head. Group deliberation, you might think, is something like this. It's the dissemination and social processing of information. So then why does sharing matter? Well, sharing matters because at the beginning of the day, different agents have different pieces of information. So sharing spreads around the information so that different agents can process the information. But on this picture, forgetting also should obviously matter because forgetting is what controls whether or not the information stays in the group. If the information is forgotten, then it can't be shared and processed. Right? So that's why forgetting and sharing both matter. But you might say, look, this is all very interesting. You've now shown me that if we're trying to predict group performance, then we should see how they forget. That might be relevant. But look, what we really care about is getting better group outcomes. And we can tell people how to share information, but forgetting is not the sort of thing that we control, right? It just happens to you. You can't control how you forget. That strikes me as wrong, though. So we do control whether or not we forget things. We train ourselves to write certain things down rather than others. We manage our focus. If I always forget my friends' names, then, I could train myself next time I meet the friend. Your name's Cecilia? OK, Cecilia. Yeah, OK, got it. Right? So we can do that. We can have mnemonics. We teach kids these sorts of things. We can make conceptual connections between things. That's ways of remembering. So how should we optimize group discussion? Well, should we do things like tell people to speak up when they have something to add? Should we have red teaming? Should we have devil's advocate? How should we formulate jury instructions? These are all really good questions about how to share information. But what I think one of the upshots of this discussion should be is that maybe we should also be thinking about instructions and techniques for managing our memory. All right, so then here's the actual recap. I gave you a new model of group deliberation in which agents exchange reasons for their belief. I argued that there's a rational way that agents can manage their memory in that model, and then when agents use the rational way of managing their memory, you get polarized groups. And then I discussed this newer model, which is an extension of the original model. And then in the newer model, how agents forget seemed to make a really big difference. Yeah, that's the talk. Thanks for listening. So how should we do questions, Marcella?
Yeah, I'll just ask the audience.
Okay.
Anybody has questions? Do very formally. Comments? There's one from Michelle.
Yeah, I think I've forgotten more of my questions than I actually remembered.
I can help you with that.
So did you say in the beginning, like, what's your, I mean, I have an intuitive sense, but what's your technical definition for rational?
Yeah, so that strikes me as a distinctly philosophical question. So I take it a really big question among epistemologists and philosophers more generally, and people outside of philosophy, is what is a rational belief? And so here I wasn't trying to start with a theory of rational belief. I'm open to lots of them. Here I was trying to start with some intuitions about what's more or less rational. So what did I require? What was absolutely necessary for my argument to get this going? One thing I did require is that the rational belief is the belief that stands in the right kind of connection to your reasons. Why did I require that? Well, because in the model, each agent has a collection of reasons, and then what they believe was supposed to be the thing that's just supported by their reasons. So I have to assume that.
Okay, so a rational agent is just an agent that believes
what their reasons support.
Okay.
Yeah. So I take it that that's a pretty general claim. Mark Schroeder likes to argue explicitly for that claim. He's got a particular account of what a reason is and things like that. But I take it that lots and lots of views about what a rational belief is will also say that a rational belief is one that responds to the reasons correctly, especially if you think that what a reason is evidence. So if you think the only kind of reason there is for belief is evidence, then you're just saying that the rational thing to believe is what you have evidence to believe. And that sounds hard to deny. So I hope I'm not assuming that much about what rational belief is, but that is what I'm assuming.
There's a comment. I was an undergraduate physics major at Michigan State. The chair of the physics department had a PhD in philosophy, and the chair of the philosophy department had a PhD in physics.
All right. Yeah. So there's a big debate among philosophers about what philosophy is, whether or not it is something that's continuous with natural science or not. I don't have an answer to that question, but I do think that lots of philosophical questions can be fruitfully answered using the same sorts of methodology that scientists use, and that's hopefully what I was trying to do here. So yeah.
A question. So when you're doing the simulations, what kind of computer language or system are you using?
Yeah. So we write these simulations in NetLogo. So NetLogo is a language that's designed by Uri Wilinski at Northwestern. He's got a group of folks who keep this going. It's a really great project. So NetLogo is written in Java, and so it's a object-oriented language. But it's all kind of in one package. It has a built-in GUI. It does a lot of you don't have to deal with memory management or anything like that. And it's got all these built-in tutorials. So the really great thing about it is that we can bring undergrads into the group, for example, and just send them home and say, do the tutorials in NetLogo. And then they come back 5 days later ready to look at the models. And do we let them program the models? Not quite yet, but they can understand roughly what's going on in the models. So I really like NetLogo for that reason. It's not the most efficient language in the world, but I kind of don't care because computing resources are cheaper than cognitive resources. Yeah.
So the way you've done this, I haven't thought through whether it's possible to do the other way, but you have some limit to the number of things that can be remembered.
Yeah.
But that's exceeded at the point of deliberation.
Exactly, yeah.
Have you done it the other way around? Where you forget
before?
Before you take
yeah.
the board.
So no, we haven't done that. I'm not sure exactly how it would work. So you'd have to make some structural changes to the model, right, about forgetting. Because instead the question wouldn't be what should you forget. The question will be when do you decide to take on new information. I guess actually in that new model there were two questions. Yeah, how do you replace the evidence you already have? Or maybe you could do it stepwise. First, should I take on board this new evidence? And if I do, then what should I get rid of? We haven't done that. The reason we haven't done that is it doesn't strike me that there's an obviously rational way to decide whether or not to take on new evidence when that question means having to forget something. So the way I was thinking, so the way to motivate kind of the other way of thinking about it is something like this. You're in an actual discussion and you've gotten these new reasons. Right now, you're kind of focusing on it so you can decide what to remember. But you know later tonight you're going to go home and have to cook dinner and deal with the kids and yada, yada, yada. So it's not going to be part of your working memory anymore. So the thought is right now you've got this extended working memory, and then your later long-term memory is going to have less in it. I have no idea how realistic that assumption that is.
It's working memory that's limited, whereas long-term memory isn't.
In real life, you mean?
Yeah.
Among real agents.
And it's a weird thing to say, okay, I'm gonna make a, I'm gonna start to believe this thing, and then jettison possibly something that supports it, right? Or trying to remember the key case.
So I actually don't think that's so weird. So suppose you're working through a really hard idea, and you've just finally figured it out, and you realize, okay, it's a really complicated idea. It's got these 17 steps. How am I going to remember this? Oh, well, the intuitive idea is this, and then you focus on the intuitive idea, and you end up remembering the intuitive idea instead of all 17 steps of the author's argument or something like that.
Yeah. I guess that's true.
So look, the goal here was to try to convince you that there's a rational mechanism by which polarization could occur. Folks like you are experts in answering the question and how realistic that is. I don't know, and importantly, I probably should have said this in the talk. So I don't claim that actual political polarization occurred by this means. I don't think that what's going on in our current political circumstances is rational. Believe polarization. The goal here is just to better understand the contours of what mechanisms could and could not, might or might not be in play. Yeah.
In the political setting, there are special interests which are not taken into account.
Totally. Yeah. Right. Yeah. So I take it that among political scientists, the standard view is polarization comes from having different interests. So it has nothing to do with us just disagreeing about the facts or disagreeing about what to do in light of the facts. Yeah. Yeah.
Have you thought about, this is a very cognitive kind of logical model
Yeah.
of rationality, fine.
Yep.
But what about pragmatic kind of rationality? Like it's
Yeah.
practically not rational for me to disagree with my boss.
Sure, yeah.
Or maybe my wife.
Sure.
So sometimes I know people have modeled certain types of interactions
Totally.
like this where
Yeah.
if I'm in a community of a certain dominant religion, it's not rational for me to disagree with.
Right.
A more pragmatic thing, not about where my reasons are to minimize conflict.
Yeah.
Or
So those are practical reasons rather than evidential
I
reasons.
might think that this is wrong.
Yeah.
I might think, look, evolution is true, but my boss thinks that my boss is a fundamentalist, and I don't want to disagree with him.
Yeah.
Right. So have you thought about? It seems like it would fit into your models with
Yeah.
a little tweaking.
So yeah, we could do that. So Cass Sunstein has a paper from, I guess, 2000 or so, where he tries to say, look, you could obviously have rational polarization, and what he means is that kind of rational, practically rational deliberation, polarization. There's also work from Joe Halpern at Cornell, and he also has a model in which he claims that there's rational polarization. And what's going on in his model is that the agents have to choose how much computational resources to put into things, and that sounds like a practical decision too. So there are models of rational polarization that are rational in that practical sense. What I was aiming for here is what I took to be a harder target, which is, could it be the case that we could ever share our evidence and then rationally still form different groups about what we believe in light of having shared our evidence? What this shows against, I think, is, something that's interesting, and again, I'm not trying to claim this is realistic, so there's got to be a lot of steps here from the philosopher to actual application. People say things like, oh, political polarization, we just need to communicate more, we just need to listen to each other more, and I think I've shown that that's not enough. Just sharing more information does not mean we're going to get less polarization, even if everyone's acting rationally in light of that shared information.
So if you start with two polarized groups as your initial condition, is there any hope of convergence?
Not with coherence-minded agents. So I seriously doubt that real agents are coherence-minded. And real agents are often motivated by all these practical things that have nothing to do with their evidence about abortion or tax policy or anything like that. They're more concerned about, will I be able to pay my mortgage and will I have food? You know? So real polarization, I think, is much more empirically complicated than the kinds of models I'm discussing here, unfortunately.
Okay, any more questions or comments? Michelle, it seems to be. Okay, go for it.
I'm just thinking about this forgetting thing or this memory management strategy.
Yeah.
One important thing that people do is they chunk their memory.
Sure.
So they get lots of things in a collection and eventually like, okay, I can hold 7 units in my
Right.
memory, but what unit is can grow.
Right.
So I wonder if what sort of thing you would see if you added something like that.
Yeah, I don't know. I'm interested in that though. So the methodology that I really like to stick with is using as simple model as possible. So most of the folks in this room are probably familiar with the reasoning there, but the idea is with really simple models, we can understand how we get these complicated patterns out of the simple interactions. The more little pieces you add in, the more complicated it gets, and you might not understand what's going on. I do think that it should be tested. We should work on seeing if variances like that get rid of the polarization. I'd be kind of surprised that if it did. Just because where the polarization comes from here is from getting rid of things that don't support my view in light of a limitation. So I take it that if we added in a kind of clumping, we'd still have limitations, but at the edge cases, we'd still end up getting rid of things. Well, I think it would be rational to get rid of things that don't support our view. The same line for supporting coherence-mindedness would give you that. So you'd think, so in all likelihood, the same mechanism would be in play, that the kicking out things that disagree with me at the edge of my memory. That mechanism is the thing that causes polarization in this model, and I imagine it would still occur in that model too. But it would be worth knowing whether or not that breaks the result. So yeah.
Okay, all good. All right, thank you so much.
Thank you guys.